Helen Keller once said that everything has its wonders, even darkness and silence. So where are we? Floating on a rock? Flying through space? There's no way of knowing for certain. But science has begun to paint a picture of how the future might unfold. So let's begin the journey to the end of time. This is the world, 197 million square miles. If I covered 100 square miles an hour every hour for the rest of my life, I'd still only say half of it. Humans have been studying science since the beginning of mankind. With countless scientists making millions of discoveries, we're only scratching the surface. In the winter of 1995, scientists pointed the Hubble telescope at an area near the Big Dipper. This spot was dark and out of the way from the light pollution from the other stars. The location appeared to be empty, and the experiment was thought of as risky. Over 10 days, the telescope took close to 150 hours of exposure of this area, and what came back was extraordinary. An image of over 1,500 distinct galaxies. Now let's take a step back to understand the scale of this image. If you were to take a ballpoint pen and hold it at arm's length in front of the night sky, focusing on its very tip, that is what the Hubble telescope captured in its first deep field image. In other words, those 1,500 galaxies were seen in just a tiny speck of the universe, approximately 1/2,000,000th of the night sky. To put all this into perspective, the average male is about 1.7 meters tall. With Earth's diameter being 12,700 kilometers, that is nearly 7.5 million people lined up head to toe. Now, you may think that the moon is relatively close since it dominates our night skies, but in reality, the moon is over 380,000 kilometers away. That is enough space they could fit 30 entire Earths in between the Earth and the moon.
Perspective is a tricky concept. Like Ryan said, it could be big with the Hubble telescope. They're zooming in on things. It's things that we probably wouldn't see if we hadn't taken a bigger picture. And we're going to look at the small picture. The smaller picture is the smaller things that are inside us and make us up. Not cells, no, smaller. Atoms, molecules. Now, with perspective in these things is that, we know they're there, and we know where they'll be, but do we? The problem with knowing where they'll be is that we don't. If we know their speed, and they're always going somewhere, we don't know their location. But right now, let's just say we have an accurate prediction of their location. Like most of my atoms are here. But how fast are they moving? You can't know that. Literally can't. The reason is because of the Heisenberg uncertainty principle. The Heisenberg uncertainty principle states that the position and velocity of an object cannot be measured exactly, ever, for anything. Now, I know what you're thinking. There's a lot of big things, like my hand. If I move it like that and test it with the radar gun or something, which is quite inaccurate, look it up. But if I move it like this and test it with the radar gun, you know where it is at maybe all times. From your perspective and your inadequate measuring tools, you actually probably wouldn't. But you get the gist here. In reality, it's a bit harder than that. You see, the way particles move, we can make predictions on things, like where a car is and how fast it's going, but we don't know the exact location of it in the universe. That goes with everything. You see, the perspective of one man is weird. Really weird. For instance, if you were put in an empty universe, let's just say you can breathe with your own little air bubble, and you have something else going in an empty universe, what happens is you're going 0 miles per hour in an empty universe. This other man is going 100 miles per hour in an empty universe. He's going 100 miles per hour right past you. This is you. This is the other man. He's moving. Now this man zooms past you, but the thing is, he doesn't think he's moving at all. No, he thinks you're moving at 100 miles per hour right past him. No gravity, no nothing. One push, and he's being pushed 100 miles per hour right past you. This is because of your perspective. You see, from this point, everything is moving. And they're moving because of the perspective we have on reality and the universe. This man right here isn't going any miles per hour, and that's measured. This man's going 100 miles per hour. But if he's going 100 miles per hour, this man is now also going 100 miles per hour, because they can debate this forever and ever. He gets a speed gun out, man 1, and he's going 100 miles per hour, and he measures him. This guy seems to be going 100 miles per hour. You see, they don't know where they're going. They don't have any markers. It's just a black room with the little bit of light on that guy, this guy, and this guy. And the thing is, he passes him. They both think the other one's going 100 miles per hour. Or rather, they both think the other one is still. They can't tell the difference. That's because of their unique perspectives. That's just one part of perspective. That's not even on the small scale. That's on the universal scale.
And there you have it, 2 different themes of perspective. One being a molecular level by Caleb, and one being more of a grand scheme of things from Ryan. And what I've learned, while both of these are both right, it's just that according to the dictionary, perspective is a particular attitude toward a way of regarding something, a point of view. Sorry guys. I'd like to thank Ryan here for his perspective on this, and I'd also like to thank Mr. Anderson here for his perspective as well. Ironic, huh?